Delta to Y equivalent circuits. What, how, and why? Resistors RA, RB, and RC form a delta interconnection because the structure looks like the Greek letter delta. On the other hand, resistors R1, R2, and R3 form a Y interconnection because the structure looks like the letter Y. The objective of a delta to Y transformation is to transform the interconnection of the three resistors between nodes A, B, and C from one structure to another. But we cannot transform the delta into the Y simply by changing the shape of the interconnections. Saying that the delta connected circuit is equivalent to the Y connected circuit means that the delta configuration can be replaced with a Y configuration without changing the terminal behavior. Meaning, for the two interconnections to be electrically equivalent, the resistance between corresponding terminal pairs must be the same. For the delta connection, the equivalent resistance between A and B is RC in parallel with the series combination of RA and RB, so we can use product over sum. On the other hand, for the Y, the equivalent resistance between the same two terminals is R1 plus R2. So, for the two configurations to be equivalent, these resistances must be the same. Following a similar procedure, we can get equations for RBC and RCA. It is this system of equations which allows us to solve for the resistors of one interconnection in terms of the resistors of the other. So, for example, if we wanted to get resistor R1, we would do equation 1 minus equation 2 plus equation 3, eliminating R2 and R3 and solving for R1. With similar algebraic manipulation, we can find R2 and R3 in terms of the three delta resistors. Notice that the denominators are all the same, but the two resistors in the numerator are the resistors adjacent to that resistor. So for example, for R1, the two resistors in the numerator are RB and RC, the two resistors next to it. Using the delta to Y transformation, we can find the equivalent resistance of complicated networks. For example, in this Wheatstone bridge, converting this delta to a Y allows us to see which resistors are series with which and which are parallel with which, when it was not possible beforehand.